There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromide, lithium, beryllium, and barium. Isn't that interesting?
3, 2,
I hope you're all paying attention. There's going to be a
fire.
short quiz later on.
Okay.
There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay, everybody. Hello, Al. How are you? I'm Chemical Charlie.
And I'm Peggy Pepin.
And we're going to do a little demonstration with the Phenol Red indicator.
Phenol Red indicates the pH level.
Okay, and that's right. And this is the structure of Phenol Red in acid solution, and it will be yellow in acid solution. But if a little hydroxide is present, it will pull off this proton and produce the basic form of it, which is red. So, Pi Guy, let's take some tap water here and put some of that indicator in, see what the pH of tap water is. As you all can see, what color is it, Pi Guy?
It is pink.
Pink, indicating that it's a basic solution. Now, it's not real basic. It's only slightly basic, maybe pH 8 or 9. Now, Pi Guy is going to blow his breath in there and see what happens. Let's okay, very good. They made a little mess here, but that's good. All right, so it obviously turned from a basic solution to an acidic solution. What's coming out of your breath?
Carbon dioxide.
Carbon dioxide. Now, remember,
mostly nitrogen
and oxygen.
But
not as much oxygen
still,
as when you breathe in, because you use the oxygen. You don't really use the nitrogen. But
there is still some carbon dioxide coming out, and
all right,
that's the part that matters.
All right, so to explain this, carbon dioxide gas from his breath reacted with water to form aqueous carbon dioxide. The aqueous carbon dioxide reacted with water to form carbonic acid, a very weak acid. All right, now I have a double arrow there. And the carbonic acid reacts further with water to form the bicarbonate ion and the hydronium ion. Okay, so the hydronium ion is responsible for making this color go from pink to yellow. Now, if we added some base to this, it would become back to be pink. But we're back, and
okay,
we've got a little ammonia here. We wanted to get a little base. Now, ammonia is NH3. And NH3, and that has this 2-electron pair, which is able to attract a proton to it. So it's a proton acceptor, and therefore it's a base. So it will pull a proton off of water and produce the ammonium ion and hydroxide. So that makes it a base. This only happens to a few percent. It's not, it doesn't go to completion by any means. But it is a base. It's a weak base. All right, so I'm going to first try this ammonia. I've had it around. I hope it works. All right, let's put a few drops in and stir it up. Okay.
And it works.
All right.
You can clearly see.
All right, now let's see if I can get this to go back. And I can do one other thing. I have a little bit of sodium hydroxide here. Let's see what happens if I put that in. And you can see it goes back to pink. All right. So this is a nice little demonstration of acid-base behavior. And I hope you can use this in your classes if you're a teacher, and you enjoyed it if you're a student.
Thank you for your attention.
And we'll see you next time.